My name is Dr. Yeap Ban Har, and I will share this problem with you. This represents 1. In our problem, we have a lot of this and a lot of this. Remember, this represents 1. I wonder what this represents. And we have a lot of this. I also wonder, what does this represent? We also have a lot of this. In our problem today, we are going to make use of 6 pieces, and you get to choose whether you want to use this or that. How many of this, how many of that is entirely up to you. Make a number using 6 pieces. How many numbers are possible? What are they? And can we try to divide those numbers by 3? Remember, when we solve a problem, we try to solve it in more than one way. Hopefully, you can get method 1 and method 2. And perhaps, on clever days, you might even get method 3. I wonder if today is a clever. Also remember, we agree to listen. We do not need to agree. Sometimes, when discussing things with our friends, we may have different opinions, different ideas, different solutions, different answers. That's all right. We agree to listen. We do not need to agree. Let us now try to solve the problem. Method 1. We know that this represents 1/10 because this represents 1. 10 of this make this. So this is 1/10. How about the pieces here? What does this represent? This stands for 100th because 100 of this make that. 10 of this make this, and 10 of this make that. So 100 of this make that. So we know that this represents 1/10 and this represents 100th. Can we make a number using 6 pieces? I can make a number is that 7 pieces? But I only want to use 6 pieces. Maybe I will do this. In this problem, we want to make a number using 6 pieces. 1, 2, 3, 4, 5. 5 tenths and 100th. We can write that number in the usual way. 5 tenths and 100th. Some of us also read this as 51 hundredths because there are 51 of this that make this number. Can I divide 51 hundredths by 3? "51" is really 30 and 21. Is it quite easy to divide 51 by 3? It's not hard, isn't it? We get 10 from here and 7 from here. 51 divided by 3 gives us 17. And if we know that, we know 51 anything divided by 3, including 51 hundredths divided by 3. We get 17 hundredths. Method 2. Is there another number we can make other than 51 hundredths? I suppose we can make use of only this. That's another number. Or only that. So here we made 6/10. We know how to write 6/10 in a usual way. We also know how to write this number, 6/100. And we know how to write it in the usual way. Are these numbers quite easy for us to divide by 3? It's not difficult, isn't it? 6/100, 6 anything divided by 3 is 2 of that thing. So 6/100 divided by 3 results in 2/100. Likewise, 6/10 divided by 3 results in 2/10. Method 3. Some of us think that it is possible to get a lot of other numbers. The question is, are there so many possibilities that it's impossible for us to find them all? Or is it possible to find every single one of the numbers we can make using 6 pieces? What if we use only the tens? And then later, we use 5 tens and 100ths. And then later, 4 tens and 200ths, 3 tens and 300ths, and so on. Can we make a systematic list? Have we managed to get every single possible number using 6 pieces, either of the tens or the hundreds? I leave that to you. If I've missed out any number, can you add to the list? I have tried to get every single possible numbers by working systematically. Can we divide each number easily by 3? We have done this, we have done that, we have also done this. How about 15 hundredths divided by 3? Is 15 divided by 3 easy? So you can figure out 15 hundredths divided by 3. How about 24 hundredths? Is 24 divided by 3 quite easy? Then you can use that answer to figure out 24 hundredths divided by 3. Today is a clever day. We have more than 3 numbers that we managed to make for today's problem, which is make use of 6 pieces of the tens and or the hundreds to make numbers. What numbers are possible? Dear colleagues, that is one way to present an anchor task. There are many ways to present anchor tasks, but whatever we do, make sure we provide students with the opportunity to learn whatever they need to learn through a single problem. To paraphrase Paulia, it is better for students to solve one problem in 5 ways than to solve 5 different problems. Provide ample opportunities and exploration before structured learning. That's from Dean's theory. Provide concrete materials. Provide visuals, pictorial representations before they move on to abstraction. That is Bruner's CPA approach. Make sure there's ample opportunities for interaction and conversation that is based on Vygotsky's theory. Also, Piaget's idea of children using their own natural spoken language to grapple with abstract ideas. Focus on conceptual understanding rather than tricks, formula, procedures. That is Camp's theory. In a structured discussion, you would expect the struggling learners to be able to come up with at least one method outlined in Method 1. For average learners, they should be able to come up with Method 1 and Method 2. And if they're advanced learners in the class, Method 3 and beyond are some possibilities for them to challenge themselves. In this video, we see how we can implement an anchor task and conduct structured discussion.